Hi, in this video we're going to look at answering question 8 of the practice paper 2 from Tupton Hall School. I've made this paper suitable for candidates who study AQA, but it's also possible that you could do this if you're studying other exam boards as well. Just check that the questions are on the syllabus that you're following. As ever, if you want any more information you can ask me on Twitter. Okay, let's have a look, see what question 8 is asking us then. It says, figure 1 shows the curve with the equation y equals 2 plus 3x minus x squared. That's this curve here, the quadratic, and the straight lines L and M. Now, there is an extra bit of information that you get on your question sheet that's not on the video, and that is that L is actually a tangent to the curve at the point A here. Okay, so we're going to find an equation for L. Well, thinking about what we know, a tangent means that it's got to be something to do with this. How do we find a tangent to a curve? Well, that's when we can differentiate it. So let's take our function, which in this case is y equals 2 plus 3x minus x squared, and find dy by dx. So this is the gradient function. That's going to give us 3 minus 2x. So my gradient function at any point of this curve is 3 minus 2x. The point that I'm interested in is this point here, A. Now at that point, the x coordinate is 0, so it has a coordinate 0. I wonder what the y coordinate would be. If you're shouting it out hopefully at me, we can find it from the curve here. Look, it crosses at 2. So we know the coordinate at this point. Now if we put the x coordinate in to my gradient function, we can say that so dy by dx at x equals 0 gives me 3 minus nothing is 3. So it gives me a gradient of 3. Okay. Right, so we've done that. Now, what else do we need to know? Well, we could do with finding an equation for the line. That's what it's asking us to do, find an equation for the line. So we should use y minus y1 equals m x minus x1. Y minus 2, we decided that point was, equals 3x minus 0. It doesn't ask us for an equation in any particular form, so I'm just going to tidy this up a little bit, and let's go with y minus 2 equals 3x, or maybe we could have 3x minus y. So I'm bringing everything across to the right hand side here. So 3x minus y plus 2 equals 0. That looks like a nice neat way. So plus 2 equals 0. Okay, we've found an equation for the line. Let's look at part B. Okay, so this part B says that we're trying to find the coordinates of the point B. Okay, the line M is the normal to the curve at that point, and L and M are parallel. So if this is a normal to the curve along here, then the gradient of the tangent at that point, let's just kind of draw that in if we can, the gradient of the tangent at that point would be minus 1 over M, where M is the gradient of the line. Well, I know what M is. We worked it out before. We said it was 3. Okay, so the gradient of this line is minus 1 over 3, or minus a third. Okay, now what else do we know? Well, we also know that our gradient function, was dy by dx, and it was 3 minus 2x. Now, we should be able to work out the value of b at this point using this information, and we know that this equals minus a third, at that point. So let's have 3 minus 2x equals minus a third. If we find the value of x, then what we've actually found is this coordinate, the x coordinate here. We can then work out what the corresponding y coordinate is. Okay, let's think about how we're going to do this then. I don't like having a minus 2x particularly. I don't like particularly having this minus a third either. Let's see, let's multiply everything by 3 first. That might tidy things up a little bit. So then I've got 9 minus 6x equals minus 1. Let's take 9 from both sides. So minus 6x equals minus 10. Divide by 6, so x equals 10 over 6. Which we can cancel down a little bit further to be 5 over 3. So x is 5 over 3. Okay, let's mark that on my picture. There we go, 5 over 3. Now if we substitute that into my function y equals 2 plus 3x minus x squared, then we'll find what the corresponding y value is. So y equals 2 plus 3 lots of 5 over 3 minus 5 over 3 squared. Then we've got y equals 2 plus 3 lots of 5 over 3 is 5 minus 25 over 9. Okay, so we've got 7 minus 25 over 9. If I put 7 over 9 as well, then I get 63 over 9. So we'll run out of space a little bit, but 63 over 9 minus 25 over 9 is going to give me what my y value is, which is going to be 38 over 9. Which is, again, is not particularly nice, but it is what it is. So my b coordinate, so b is 5 over 3, 38 over 9. Okay. As ever at the end of these videos, we like to do some revision card notes. Again, this is another differentiation question without, again, saying differentiation. It didn't say dy by dx anywhere, but it is, in fact, the gradient function. And the clue was all about the gradient and the fact it's a tangent and a normal. These are keywords that we're looking at on these sorts of questions. Take care when you're substituting values back into equation, you're subbing it back into the right equation. Very easy to do the wrong thing, and as ever, read the questions carefully. So be careful, good luck, and see you soon. Bye.